Hello and welcome to Creighton in the Community. I'm Joyce Bunger and I'm going to be your host for today's show. Would it surprise you to know that Creighton University students are playing a pivotal role in protecting the environment? Some new majors have been offered at Creighton University and we're going to talk about them today. I'm here with Dr. Michael Cherney. He is a professor and he is the interim director of the Energy Studies at Creighton University. And it's been changed from majors to studies. Tell me why.
Well, it's originally the program was called an energy technology program. When we first drafted the grant for this project, that we were planning on also including some vocational education as part of it, which would have been a new area for Creighton. In the meantime, Metro Community College started up a program in sustainable energy, and what we decided was we'd much rather use our resources to complement what they were doing. And so we're actually creating two courses as part of the new program where it's combined with Creighton and Metro students together. One of those classes where we focus on solar energy in terms of photovoltaics will be taught on the Creighton campus, and the other one where the focus is on convective heating will be taught on the Metro campus.
Another example of Creighton's partnerships with the community. I like to hear that. First of all, let's just do a quick review about the various programs that are offered at Creighton University.
Well, there are really three programs that branch into sort of this sustainability area. The first of these is the atmospheric science program. What we're going to be doing is we're going to be really, through our program, we've gotten some additional funds and we're going to be able to enhance what's going on in that program.
Because it's been around for a long time.
Yes, and it really has two focuses. One is more along the lines of basic weather prediction. The other is a more advanced course of study, which really worries about computational models, modeling what is going to happen next. And
such as predicting storms?
It's even more than predicting storms.
Like what?
It's really building up the models so that you can say, how much energy is Omaha going to need tomorrow? And how much energy is it going to need an hour from now?
So it's like actuaries of environment.
In a sense it is.
Wow.
And it's actually really important because as we bring more renewable resources online, and these can go in and out depending on how the sun is shining and how the wind is blowing, we need to know how to bring the traditional resources back online. And it turns out to get things going, we really have to have good forecasting both on the 1 hour basis and on the 1 day basis.
Okay, so we've got atmospheric sciences.
Right. The second program that's already in existence is the environmental science program. There again, they go off in three different directions. First of these is a good partnership with atmospheric science. The second is a good partnership with biology. And the third is a course that really tries to bring in the human aspects of environmental science. If we are going to really make change happen, you can have good science, but it's being able to communicate with people and have people understand and have people make life changes. These are the things that are really going to make change happen.
In another segment of the show, we talk with Dr. Leiter in communication studies, and he talks too about public policy. So is that kind of what you're talking about, going into communities and actually encouraging people to make changes in their lives? Is that the human aspect?
That's one of the human aspects that's in the environmental science program. That's also one of the aspects that's in the new energy program.
So let's talk about the new energy program.
Well, the new energy program is actually something that is both innovative in terms of what is taught and the way that it's taught. Mm-hmm. We're offering two new majors, a Bachelor of Science in Energy Studies and a Bachelor of Arts in Sustainable Energy. Both of these programs really share a common core, and the core is what's really exciting. These courses are all interdisciplinary courses. You'll have courses that are taught by an engineer and someone from English. You'll have a course that's an engineer and someone from journalism and mass communications. Someone from history and someone from physics doing a course together. And so it's really addressing the problem from the way the world really is. It's not we live in these segmented pieces, but what we do is we live in a world where it's all mixed together.
Well, take me back to the beginning. How did you get everybody around the table, or who did you choose to be around the table?
Well, first I want to give credit to the people who made this possible. Father Schlegel has really shown a commitment to sustainability on this campus, and a big part of why we're able to do as much as we are is he's given back all of our grant overhead money back into the project. Most universities would have taken that 40-some% and used it elsewhere. The second thing, though, is we've got to give a lot of credit to our congressmen. Lee Terry and Ben Nelson really helped make this happen for Creighton. Although this was a grant proposal that we really got support from our delegation in Washington. The third piece is the Omaha Public Power District, that again we're having contributions from them to make this program happen, all of which are truly substantial contributions.
Wow, it's a huge coordinated effort, yes. So when you went to, you now have the funds to grow this program. Who was around the table to help build it?
Well, what we did is we started with a set of focus groups. We worked with faculty, we worked with students, and we worked with people from area businesses. What we discovered was actually we as faculty members aren't nearly as creative as the people in business and our students are. That we learned a lot about what potential future employers would really like in terms of our graduates. And what we learned were some things that would make sense not just to our program, but to programs across the board. What they wanted were people who would be lifelong learners, people who could work well in teams, people who could communicate well both in a written fashion and an oral fashion. Also, they wanted people who were willing to be innovative, people who were willing not just to follow a procedure. And so what we did is we started to build from there. Well, in creating the curriculum, what we saw was there were two universities in the United States that seemed to match very well with what we were trying to do. The Carnegie Foundation had put out a report that described how engineering education should really be done in America. And lastly, we looked at our own Jesuit tradition. And what we saw was at these two outstanding schools in the Carnegie report and in our Jesuit tradition, there were really these common themes which encouraged us to address problems not as individual pieces, but as a common whole. Again, it's sort of the way that Creighton tries to do its education. It's not we just worry, is this person a good physicist? Is this person a good chemist? But what we worry about is the whole person. It was also really interesting that the pedagogies at all of these places came across in very, very similar ways. And what we were able to do was really take something that we could go back to the spiritual exercises of Ignatius of Loyola and say, this is really a good way to learn. And the whole idea is it's not creating a curriculum where everybody marches in lockstep. What you do is, first, you get people to identify what you want in the experience. And that draws out some sense of commitment from the student. Then what you have is the teacher takes on a whole lot more of the role of the retreat director, where it's listening to what they want, but not always giving them what they ask for, but giving them what they think is going to move them forward. The next step in the process is getting the student to be actively involved in the process of learning. And the final thing is to reflect on the experience, to say, what did I get out of the experience? What more could I have gotten out of the experience? And really, should I be moving on, or is it more valuable for me to go through a similar experience again.
Let's talk a little bit about the typical student. Are you seeing a typical student that's interested in this major?
It's actually, in terms of the people who have contacted us about it, it's been a broad spectrum. But it tends to fall in two categories, and that's really why we created the Bachelor of Science and Bachelor of Arts.
Yes, I'd like to know about that.
The Bachelor of Science is really meant to be a degree where you get people to have the science, the math, and the engineering background that they need to succeed in a professional environment. But in addition, it brings in the ideas of what are the relevant laws, what are the relevant public policies, what are the relevant human aspects. I mean, how do we identify user needs? How do we communicate with potential clients? All of these things go together to build that Bachelor of Science degree. So if you look at it, it's really a set of 9 courses, it's a set of 25 courses, about 9 of which have a math, science, engineering focus. Another 5 have more of a humanities focus, and the last are really independent projects. Because what we've seen is the way people learn best is give people a project, give people a goal, and in working to the goal, they actually can learn a lot of the things, but in a non-traditional way. On the other hand, that non-traditional way is an awful lot like the way that people really have to do things in the real world. It's when you get out of school, it's not you're going back and taking a series of classes again, but what you're doing is you're discovering a lot of things on your own that are relevant to the particular thing that you're working on.
Now, how are you recruiting students into this program?
Well, to be honest, the first year recruiting is happening by itself. We're going to have more students than we were originally planning on dealing with. Part of this reason is we can still let freshmen come into it, and we're clearly seeing a backlog of freshmen who are interested in doing this, and then we have the incoming class. But even there, we're looking at a very different way of bringing people into the program. It's not that you come to Creighton, you spend 1 or 2 years working on the general courses and then say, this is really where I'd like to settle in. What we're doing is we're looking for people who really are seeing this is an idea that I've had all along. This is a passion of mine, and what I want to do is I want to follow through on this passion. And so entry to the program is actually much more like the entry to the honors program, that we're having an essay that you're going to write in the beginning, but what I think is even more fun is we're sending out a kit with a solar cell, a resistor, and an LED lamp, and giving it to the students in an envelope and say, we're not going to tell you how to do this, but what we want you to do is hook these 3 things up, get the light bulb to light up, and take a picture of it, and that's part of your application. So the real idea is getting people to use the resources around them. It's a doable problem, but it's also something to make you think, and it's also something so that students know what they're getting into when they're starting our program.
Marvelous. An amazing program at Creighton University. And when we come back, we'll zero in and focus a little bit more on one of those programs. In an effort to learn more about one of our specific programs at Creighton, I've invited Dr. John Chalice. He is the professor of biology and he is the director of the environmental science program. Please tell me about the environmental science program.
I'd be happy to, Joyce. The program started in 1991 and it was inspired by interest among colleagues in different departments to try and do something together, truly interdisciplinary. So currently we have 15 core faculty from 6 different departments that span the natural sciences and sociology, political science, philosophy, and we think Jay Leiter is going to join us in communications. That's a plug there. But so we're a rather broad and diverse group. The program is grounded in the natural sciences. Our students are required to take a curriculum of introductory courses in chemistry, biology, and atmospheric science. And then they supplement with some additional core and what are called areas of specialization. Now, Dr. Cherney talked to you sort of broadly about those areas. I'll flesh that out just a bit more. So the component that strongly involves atmospheric science and physical science is called global environmental systems, and that gets into how the world works at a very basic physical level, and climatology, physical oceanography, that sort of stuff. And then the second track is called organismal and population ecology. There's a large contributing set of classes from biology, are sort of the environmental side of what we do in biology. And then we have this third track, as Mike said, that's the society interface with the environment. And we have courses in environmental policy, sociology, demographics, which is human population change, environmental ethics, and a new course in rural sustainability that Dr. Dilley teaches, and a course that Jay Leiter teaches in communications in the environment.
The young people in our high schools, how are they learning about this major? Is the way we're teaching science in the high schools changing so that they immediately evolve to want to come into this major?
I think some of both. I think it's quite variable out there what opportunities they have to take an environmental science course in high school. And the larger high schools do very often offer earth science or environmental science, but we can't presume that for all our incoming students. But I do think that we have a fairly unique set of students in our science majors taking environmental science. I think they self-identify with this program, some only after they arrive here and are exposed to new ideas, new thinking. Others come in with a clear vision, mission. This is what they want to do in life. And so, it really is a blend.
What are some of the careers that they'll have when they graduate with this?
It's really fascinating. We've been doing some tracking of those students, and in the 20 years and roughly 200 graduates, we know that roughly 50% go on to earn either master's or PhDs, and approximately 25% do health profession degrees, and then a variety of other things that they're doing with their degree. And they're working in fields as broad as oceanography, geoscience and groundwater hydrology. They do climatology. One works up in northern Alberta, and others in Fairbanks, Alaska right now doing that work. Toxicology.
Give me an example for
yeah.
What are some, like in climatology,
Okay.
What do they do? What's their job?
Well, I'll take the, Chris Heimster is a grad who went on to do a master's and PhD at University of Wyoming, and then a postdoc at Colorado State. He now works in Fairbanks, and he's working above the Brooks Range for some of his work with snowpack and looking at how that changes seasonally, interannually, budgets of energy in and out. The high northern latitudes are changing very rapidly right now, what's called the disappearing cryosphere. And of course you may know that the glaciers are receding, ice is melting off the ice cap. And he's part of that story, putting the threads together to help us understand better what's going on.
What are your students working on?
My current students, one I just had a master's student defend on Friday. He's been working with me on coastal ecology, something we'll see in an upcoming video segment. And his project was to put together remote sensing data that we collected with the University of Nebraska in a joint aircraft mission in coastal reserves between the Gulf Coast and the Mid-Atlantic. And he's looking specifically at salt marsh vegetation and how they differ in different tidal regimes and different climatologies.
So this is the Creighton University Coastal and Estuarine Ecology class, and we've been on the road now for about a week and a half. We left Omaha on May 17th. Last week we worked in West Florida on Apalachicola and St. Joseph's Bays, part of the NOAA Research Reserve System. Today we'll be out on the Florida Keys Marine Sanctuary, Lou Key Reef, and this is an outdoor classroom. There's no better way to show students ecology than to take them out on a coral reef. There's more biodiversity per acre there than just about any other habitat on the world. And it's a very productive and important marine system, obviously critical to the Keys as a holistic ecosystem.
Is if you would just keep your eyes open and watch for those guys. Don't try and catch them. They are poisonous. They will sting you. If you don't know what they look like, there's a sticker right here on the helm that you can take a look at one.
While we're out at the reef, we're also going to do a few measurements today. We have a multi-sensor sonde, which will be dropped at each station to record data. It does it on its own. It will be recording salinity, pH, oxygen, depth, turbidity, and probably a few other things. We can simultaneously measure about 10 properties of water, and we'll do that at each of 3 dive sites. We'll also be taking plankton samples to look at the small critters in the water, but our main focus will be the bottom community and the reef system.
The reef here is no more than 30 feet deep. That would be our maximum depth. That gives us unlimited bottom time. We don't have to worry. It's a very safe place to dive with students. We don't have to worry about the decompression charts because we never exceed them with these 3 dives. So 3 dives in the water, about 3 hours of water time altogether.
Some of the most important work that we're doing is very simple. It's simply photographic documentation of the habitats. We have several underwater cameras. In fact, I think altogether 5 or 6 different devices, and we're able to very easily and readily, by picking the right conditions, take photographic assessments of the conditions of these different marine communities we're studying. They're also learning techniques in water chemistry and water sampling that are useful for the overall research objectives of our center. And then next week, when we get them into the marshes up to their knees in mud, that will be another very useful part of this process.
I am seeing new regenerating corals, especially the Montastria annularis, that star coral. It sort of grows, it's a greenish brown cover, and it is coming back here. That stuff was bleached heavily in some events in the 90s and early 2000s, and at least that is good to see some regenerating coral here. Who knows what lies ahead, but you know, of all the areas down here, this is one of the healthiest reefs. Fish, really big rainbows. I think the best thing I saw was that school of young midnight parrotfish.
Those parrots.
I've never seen a school of midnight parrotfish.
That large, like that.
Yeah.
I saw that too.
There were some really huge parrotfish, and
oh, I got a sweet, big old school of parrotfish.
Yeah. I would say I saw
The blue one?
a couple parrotfish that were at least a meter in length. Anybody see any grouper?
Huh?
Bass sauce? Black grouper? No? Ever see these harlequin bass? They're down on the sand often. Little stranded bass. Schools of blue tang today? Yeah. John Ollie, and he is now a certified diver. He's joined the ranks of the diving community. And Danielle has just received paperwork making her a dive instructor, which is a pretty significant achievement for a student of her age, and means good things ahead for her.
So,
2 really big green moray eels. We saw 2 fowlfish. I saw some big gray angelfish, some queen angelfish. Yeah, I got some big barracuda. Me and Carla swam next to a huge tarpon. It's probably the biggest tarpon we've seen since we've been here.
So this was a really good second dive. We saw some nicely regenerating mountain star coral, species that's really important to this reef. It's taking quite a hit from bleaching and diseases, but showing some evidence of coming back nicely. Also saw some elkhorn coral. This is now a federally endangered species. There's a lot of effort to try and bring this coral species back, and in a couple places here on Lou Key, it's doing very well. It's not back to anything like it was 20, 30 years ago, but at least there's some nice growth, and we got some good photo documentation of that. There's some turf algae that overgrows and is considered bowed algae, but not a lot. I think there's enough herbivorous fish on this reef to keep it pretty clean and down. Dive number 3.
Last dive. Got to make this a good one. Maybe another year before I'm back in the Keys to dive with the class. So, got to make this one count. We'll see you topside.
Had a shark swim pretty close next to me. About 10 feet away. That scared me pretty good.
So, favorite fish of the day? What was your favorite fish? Your shark?
Blacktip, no doubt.
Blacktip.
He's gonna be at dinner later on.
Who saw the Maury?
Yeah,
I saw him.
Wow, that's great.
So what we're doing is we're filtering the water that we collected this morning from the reef, and we're filtering out the chlorophyll, and chlorophyll is an indicator of phytoplankton, and it's a common test to see phytoplankton levels are reflected by the chlorophyll levels. And
This
then-
is a YSI multi-instrument sonde. In shorthand, it takes a lot of different parameters.
Secchi transparency, chlorophyll A content, CDOM, nitrate, temperature, conductivity, salinity, dissolved oxygen, pH, turbidity, all that good stuff.
So you
Cool.
you follow the canal all the way around.
Yep.
You'll see these markers here.
Yeah, we know those.
Green NAS.
Yep. And there's
Instead of going this way, you just make the right and follow
yeah.
down.
Instead of going around here, go up this channel. You go under the bridge, and when you go under
That's
the
what we did
bridge.
yesterday morning, right?
When you go under the bridge, watch this shoal. Get over here to this side.
So there's been a lot of attempts to protect coastal wetlands, both in the U.S. and internationally, and it is really important. We've lost a lot of really good habitat for fisheries and for shoreline protection. When mangroves are lost, that is a loss for the whole coastal system. Miami and Miami Beach used to be primarily a mangrove swamp, and that was all cleared to make that marvelous metropolitan area, but at a loss of natural systems. Fortunately, Florida still has a substantial amount of mangrove, and now they're well protected.
I also noticed in the most recent issue of Creighton magazine, they reserved the last page for you, and it's called The Last Word, Reflections on the BP Oil Spill. Why is this topic so relevant and deserving of the last page, the last word?
Okay. Well, I think it illustrates several key points that relate to what we're talking about, and broadly to what you and Dr. Cherney talked about in terms of the central role of energy in our society. But in a broader sense, what happened in this tragedy in the Gulf is an example of outcomes that in some ways are predictable when we're not taking care of business properly, and the human element. But it starts with our rapacious appetite for resources, whether it is energy or water or precious metals,
Oil.
Gold at $1,400 an ounce today. And the environmental problems we face and the milieu that I wrote about in this essay, it does condense to three basic interacting components of this environmental crisis. That is human population growth, the per capita consumption of resources, this broad array of resources that society is dependent upon, and the environmental impacts of that resource use, whether it's in the extraction phase, the production phase, or the discard and abandon phase. All of those come together to create the potent forces that we are now confronted with. And in this essay, I first laid out what went into the mix of things that led to this acute tragic crisis in the Gulf. But my conclusion is that more broadly, it's not so much the questions of technology and science that are unanswered right now in this environmental crisis, but our inability to reconcile the human dimension with those questions. And that's where I think Creighton can really play a major role, in that we have this very strong Jesuit inquiry tradition that is not just a focus on science. You could say it is truly an interdisciplinary look at the world. And it includes philosophy, it includes religions and comparative religious studies, and it includes ethics and communications and sociology, policy and political science, history. All of these things that are at the center of our liberal arts core in this college also contribute to a worldview that is so critical if we have any hope of addressing and solving these problems.
You end your essay with, "Heaven help us."
I knew that was a forceful thing to say, but as I look at what we face, it will take divine inspiration, I'm afraid, and also human motivation and ingenuity, but not just the science and the technology. Not that those are easy parts of the equation, but the harder parts of the equation are to get people involved in, and through these other Jesuit styled inquiries, I think that therein lies the answer.
Thank you. Ben Franklin, an ounce of prevention is worth a pound of cure. Creighton is indeed doing its part. Thank you for joining us.